Hello everyone, today we will solve Leetcode 1423, which is maximum points you can obtain from cards. So let me explain you the problem first. So here we have given some cards and each card will have some number on it. Now we have to choose k cards from these set of cards such that the sum of those cards is maximum, and we can choose card either from the beginning, either from the end. So let me just tell you what do we mean. 1, 2, 3, 4, 5, 6, 1. So at this instance, let's say we have to choose 3 cards. Then in order to choose first card, we have 2 options. Either I can choose this number, either I can choose this number. So let's say I took this number. Then my current sum will be 1 plus. Now I have option, either I can choose this, either I can choose this. Let's say in this case I choose this number. Now sum will be 1 plus 6. Now for the next number I have option, either I can choose this number, either I can choose this number. So here let's say I choose this number 5. So total sum will be 12 in this case. Okay, if you think of some solution, just think of how our solution look like in an array. So assume that this is an array. Then our solution will be, we choose some element from the beginning and some element from the end. Let's say I took x number of elements from here and y number of elements from here, such that x plus y is equal to k. So we have to choose these x and y in such a way that sum of these elements is maximum. So just think of it. If we join these elements from here to here and assume that this array is circular, then don't you think this part and this part, if you combine together, it becomes as a subarray? Right? Then the problem will reduce to a point that we have to find a subarray of size k whose sum is maximum. Okay, so how we do that? Over here, one simple way is, let's say this is the array starting from 0 and there is some index from k minus 1 and dot 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 2 we have like this. So what we can do is, first find the sum from 0 to k minus 1. This will be a one window of size k. Now take 2 pointers, one from here, let's call it as I, and there is another pointer, take it as j at the last index. Now we have one solution of window size k. Now what we can do is, just to shift this, I can remove one element from here and add one element from here. So here what we can do is, we will decrease I minus minus and j minus minus, and again we'll have new window of same size. Then find the sum again and see if it is better, then update it. So let me just give you a little description like how this solution works. So in this case, instead of writing the numbers, I'll write the index. Let's say here we have 0, 1, 2, 3, 4, 5, 6. So we have total 7 number. How it works is, say indices if you want to write 0, 1, 2, 3, 4, 5, 6. So total 7 element we have and k equals to 3. Then if you talk about the first window, so the first window will be from 0 to 2. The next window will be like this one only. The next window will be from 0 to 1 and one element from the last, which is 6. And the next window will be 0 and 2 elements from here, which is 5 to 6. And the next window will be 4 to 6. So these are the 1, 2, 3, 4 window we have. So we will find some over here, some over here, some over here, and some over here. And once anytime if sum is better, then we'll update that variable. And finally, whatever be the maximum sum, we'll return it. Let me just show you the solution. Over here. So here, what I did is, first window will be from 0 to k minus 1. So I find its sum, store it into the max sum, and now we took two variables, I and j. I will start from k minus 1, j will be from last element, both will going downward, and remove the element at ith index and add the element at jth index. And if there is a max, we are getting the better sum, then we'll update the max sum, and finally we have to return the max sum over here. Now, what would be the time complexity over here? So what we are doing is, we are finding a window and then shifting this window one step. Then firstly we are going k element over here, and then again at here what we are doing is, we are removing one element from here and adding one element from here. How many times we are doing this? So if you look at the number of windows we have, okay, so first step is we'll doing sum of k element, and then after that, in each iteration, like this is the first window, and after that how many iterations we have? K iteration. In k iteration, what we are doing, just adding one element and removing one element. So k times we are doing this. So time complexity over here is O of k. And what would be the space complexity? Space complexity, we are not taking any extra space, so it will be O of 1. Okay, let's think of same problem in different way. So in last solution, what we are doing is, we have given an array and we are choosing some element from here and some element from here, such that sum of this plus this is max. But what would be the opposite of this? There is a sub array remaining over here as well. So what if we find such a sub array whose sum is minimum? Then of course the remaining element will have the maximum sum. So what we can do is, we find the total sum of the array, and out of them we just subtract the subarray of length n minus k, because we have to choose some element from here and some element from here, which is total k. Then remaining element would be n minus k. So we have to choose n minus k element from this array, means subarray of size n minus k whose sum is minimum. Okay, and if you know that sum which is minimum, then this would be the maximum sum that we need. So what we can do is, in the same way, we have given this array. What we can do is, we start from 0, and this will be, let's say n minus k is some variable x, so it will start from 0 to x minus 1. We find this first window, and again next window will be something from here to here. Actually start from 1, which will reach up to x, and again like that we keep on going. And whenever we get the better sum, it means that as we need to find the minimum, better means if you get the smaller than the current mean we have, we'll update it. Now let's think about the time and space complexity in this approach. So time complexity over here is, what we are doing is, firstly we find the sum of n minus k element, and then keep on adding one element and removing one element from here. So overall we are traversing complete array. Then what would be the time complexity, which will be O of n, and we are not using any extra space, so space complexity will be 1. Let me just quickly show you the solution for this as well. So here what I'm doing is, we have one variable which is total, which says that what is the total sum of array. How I'm computing it? Over here this loop will run from 0 to remaining only. Remaining is n minus k in this case. So till here the total would be the n minus k element, and remaining k element I'm updating from here. So total will have a total sum of this array. Now how I'm finding the min sum? So here we'll find the first window which is n minus k size, and again From remaining, what I'm doing is adding one element and removing one element. Here I'm adding, here I'm removing. So finally, if you get the better min sum, we'll update it. And what would be the answer? Total minus min sum. Thanks for watching. If you have any query or suggestion, just write it in the comment section.